AnyLogic, okay? So here we go. So AnyLogic is a platform for agent-based modeling that's built atop this language called Java. And over the past several days, you've been putting into your model little snippets of things that you might have thought are constants, things like a value 10 for the timeout till someone recovers from infection, or a value that you use to determine the number of persons to whom a person is connected. Maybe you're computing statistics for the mean number of connections for those who are uninfected and infected in the population. You're putting in these little snippets of code. And those snippets of code are written in Java, this language called Java. And if you don't have some kind of formal exposure at a very basic level to Java about what these statements mean, it can seem a little bit mysterious. This whole notion of this that I keep on using, this dot whatever. Even the use of those dots, how to make sense of those things that I'm writing down. Those cases where these semicolons for commands, it can seem quite mysterious. So I'm going to try to give a little bit of an introduction today to the relationship between AnyLogic and Java, because it's worth knowing where Java is beneath the surface, what role it plays. And then I'm going to talk about some of the specifics of it, okay? So a little bit about AnyLogic and Java as a whole. AnyLogic is very attractive and recommends itself for many people, in part because it's using these declarative mechanisms. We can draw these state charts. We can put up an event. And we know visually sort of what it represents at a certain level. And we can go in and we can look at sort of what we're seeking to represent by looking at the properties of that event. So we can say a given transition is a rate transition that goes off with a rate of 0.1. And we don't have to write a lot of code to capture that. Instead, it's done for us. We can say a timeout should occur after 5 days of time, or we can say that an event should go off every 1 time unit. And it takes care of this. And AnyLogic takes care of the how. You basically specify what you want to happen, and it will take care of a lot of the details. And this is a big difference from a lot of agent-based programming platforms. And it allows us to go pretty far in terms of describing a model. But inevitably, there's little bits of that model that we're going to have to we're going to have to specify little bits of code, okay? Occasionally, we're going to need to write and look at little bits of code. So what is this whole Java thing we've been talking about? Java is a popular cross-platform programming language. It's a language we call object-oriented because it focuses on representing things called objects, which group together the data about them. Think about a person's sex, their ethnicity, for example. It groups together that with information about their behavior. Think about their state charts. Think about being able to ask it to tell you to whom it's connected in a network. By bundling these together in a single thing, you could ask that, okay, tell me about your properties, ask it to do something for you, like to connect to this other, connect the baby to the mother. We direct those questions to in this case, the person, and the person is an object. So Java is what's called an object-oriented language, and that comes out in how AnyLogic works. We can kind of say this dot main dot, get, or dot population, and refer to that population as being sort of by referring to main, the thing that's with it's associated. So object-oriented means it's oriented towards bundling together these things in objects, these sort of actors which have properties and which have behavior bundled together. And it's very useful for representing things in the external world. So we have people, and they have behavior, and they have attributes, and we bundle them up. And so AnyLogic, this notion of a person class is a reflection of it being object-oriented. It's a class that bundles together properties, how it behaves, and the characteristics. So AnyLogic is written in Java, and it turns models into Java. When you press that build button, it's actually outputting Java code. Behind your model is Java code. And AnyLogic basically operates much of its mechanisms by taking care of a lot of the basics and allowing you to insert these snippets, these little fragments of Java code. So even when you enter a lot of those constants, like a timeout of 10, that's Java code that you've inserted, okay? And if you want to use AnyLogic in a thoroughgoing way, if you want to do a lot of basics, like create custom statistics over a population, or if you want to exchange messages between agents, have one infect another, you're going to need to use these bits of Java code, okay? Okay, now, the use of Java is significant here, and there's a lot of advantages besides understanding the models and building them to understanding it. One is extensibility. There's a massive number of so-called libraries out there that provide functionality. So you can call from your model off to a GIS library and ask it, you know, what's this neighborhood like where this agent is currently situated? What's the distance to the nearest convenience store? What's the distance to the nearest grocery store? You could ask that through Java libraries. Other Java libraries could be used to look up information on weather conditions, or look up information on to perform statistics, custom statistics, to draw value from multivariate distributions. There's a huge number of ways that you can use the variety of third-party tools out there in Java, these so-called libraries, to do interesting things with your model. And that's really powerful. Later in the week, I'll be showing you some additional tools, and there'll be demos of tools which we've built with Java to support AnyLogic. And the fact that AnyLogic runs atop of Java is really significant. It allows us to build tools easily and use other tools like profilers to see where the model is spending its time. Why is it slow? Where is it burning up that time? And that can help us find bottlenecks, help us zero in on places where we really need to think about performance. So let's talk about this just a bit. And again, we're going to dive in very shortly to the details of AnyLogic, of Java code for AnyLogic. So let's talk about the stages of what goes on with the model, though. Most of us have been working with AnyLogic in the capacity of working with these declarative mechanisms, like state charts. So you sketch out a state chart. You can look at it from a high level of a sense of what it means in terms of the possible progressions. We know if there's a transition from one state to another, either directly or indirectly, it means you can go from that state to this other state. By contrast, like this diagnosed active TB state, you know you can't go back to a TB susceptible state, okay? So basically these transitions tell you a lot about its possible behavior. And you go into more detail by clicking on them, you can see more information about the nature of this transition. However, this is not a full description of the model by any means. Even when you go and you look at it in detail, you're understanding the what of the model. If you want to understand the how of how it's working behind the scenes, all the gory details, you do actually have recourse to. And I do this maybe a couple times a year, and that's saying a lot because I teach quite a few of these boot camps, but a couple times a year I'll actually go look at Java code from this, just to figure out exactly what's going on with respect to, like, what is this self thing and when is it needed? Occasionally I'll go look at this code and I'll say, oh, it's called self here, so I'll put in self. Rare, but I do it occasionally, and this is one of the things I'm hoping to sort of make you aware of. So behind this model is Java code. And in fact, if we go and we look at our AnyLogic model, let's take this latest model we built up, this model with fertility and immigration and so on. If we go look at this, we could go in at a point, let's suppose we want to go in and take a look at that little bit of code associated with birth. Remember this code with the baby? We set the baby's location. If you press, you go there, you click in that, my cursor's in there, and you press Control-J, this AnyLogic will actually take you to the underlying code behind it, to the code that it has produced. And you'll notice it's the same as our code. It's just pasted our code in. But above it and below it is code that it has created. You notice it says execute action of. This is basically, it's testing, okay, for different transitions, what should I do? And in this case, if we have a birth transition, it's saying do these sort of things. So behind AnyLogic mechanisms, behind the model is Java code. Again, I rarely look at this. You cannot modify it. You're not allowed to modify this. You can't go in and change it. And there's a reason for that. If you went and changed it, it wouldn't know how to change the model visually to be corresponding, and increasingly the visual model wouldn't correspond to the actual code. So it doesn't allow you to change it, but you can look at it. And we have our ways of changing how it works behind the scenes. There are ways through what's called aspect-oriented programming of instrumenting this code behind the scenes to do extra things, to get it to print out for you every time it's gone across a transition, to notify you when it's received a message, to tell you every time that an agent has been created, etc. So there is Java code behind this. Behind every model, there's Java code. And rarely look at it, but occasionally you can. You can right-click on this, and you can even say open with, and you could say, I want to open this thing with a Java editor. And you can go look at this. I don't recommend doing this a lot, but occasionally it's useful. Here's person, and this is the declaration of person. They have a sex, right? Associated with them. It's of type sex. And you know, they have a default value for it and a bunch of features. So behind your model, in other words, is Java code. Generally, we don't get involved in it, but knowing it's there is helpful in occasional uses. It's kind of like being able to open up the hood of your car and say, what's going on here? Wow, it seems like we're really low in the coolant. You know, we better go get some coolant. Or it's like saying, wow, you know, there's engine oil burning here. I better take this to a mechanic. I better take this to a programmer. Okay, so Java code is behind here. And that's not the end of the story. It actually turns this Java code into something that can be run called Java bytecode, which is code behind the scenes, which allows the models to be run. Okay? Now, the build button is what goes through these steps. It takes it through these steps. It tries to understand what's going on here. It turns into Java code, and it produces bytecode. That's what that build button does. And the most critical step is, does AnyLogic understand what you mean? An example where it can't understand what you mean is if you misspell something. Or if you're referring to mortality rate, but it lives up in Maine and you're referring to it in person, and say, I don't know about a mortality rate. Or if you have a hanging transition here, if a transition is not going anywhere, it's sitting out in space. For a lot of these sort of errors, AnyLogic will warn you and say, I don't know what you mean by your actions. And what will happen, ladies and gentlemen, let's give an example of this. If I go here and I go to that birth transition, here we go. There's that birth transition. And suppose I were to put something wild in there. I just put something strange in there. I just type some nonsense. If I try to do a build, it's going to do the equivalent of squawk. It's going to say, I don't know what you mean. There's some problem. Your grammar is not good. You have a syntax error in this token. I don't know what's going on. This is its way of saying I'm confused. It can't resolve what FASD, DFAAT is. My nonsense. Now, if I double click on this, it will take me to where this was. In most cases, it's pretty good about that, and I can delete it. And the point is that those errors are coming up at this point in the transition. They're coming up when it's trying to take this sort of depiction of the model and turn it into Java code. And it can't, because it doesn't know what you mean. Okay? So here, we're often ending up, if we have errors, we're not going to get to the Java code stage. It's going to stay at this stage because it doesn't understand what we mean. Occasionally, you will end up in this Java code at what we call runtime. What I mean by that is your model's running and suddenly there's a problem. And you go and you want to look at where the problem is, and it will show you a bit of Java code. And you'll say, what the hell? I don't know what that is. And then you might want to try to puzzle out what's going on there. And often you see snippets of your code, and you can kind of puzzle out what's going on. It's not common, but it does happen sometimes. The final case where this happens is if something's really screwed up. Something is really, really confusing to it. I could try to trigger a case like this. Let's suppose we put a semicolon after this timeout. As we'll learn, this is an expression. This is a formula. We don't need a semicolon. But suppose I tried to do that, and I press this. It actually is okay with that. Suppose I did something wacko here. Suppose I did something like that. Then, it gets all confused. And some of these things may end me up in the Java code. No, it's been pretty good. It's not too bad here. It used to be worse. Okay, it's ended up in a different place. Look at that. It got all, here's a bit where it ended up in the Java code. I clicked there, and it ended up in the Java code. So there are cases where occasionally you will do something which gets it so terribly confused, it will actually show you a bit of Java code behind the model. Rare, but it does happen. So you should know this code is there. Code is there, and it shows you it when it's in real trouble, when it doesn't know what in the world is meant over here on the left, and it's typically because you've given it something wacko, or because it's crashed and you had real problems, okay? So this Java code, for a Java, someone who's familiar with Java, like a professional programmer, they can look at that code and understand what's going on. I can look at that code and I pretty much know what's going on. A decent Java programmer will be comfortable with what's happening here. Will say, oh yeah, it looks like it's doing this, and so on. Rare that we have to look at it. Quite rare in my experience, but occasionally happens. And you should know it's not gobbledygook, but you're not going to understand all pieces of it after this tutorial. But you might understand some. You will understand some. I'm going to be showing you places where if you really want to see what's going on behind the scenes, after these tutorials, you'll be able to say, oh, I understand what that's doing. That makes perfect sense. Okay? So we're going to be seeing that over the next few days. So let's talk about this. So I talked about the build button, and that's good. Okay. I could talk more about here about this, but I think I want to dive into the details of Java. So you know that AnyLogic is using Java behind the scenes. It's turning your model into Java and turning that Java into something it can use to run the model called Java bytecode. Are there any questions you want to ask about that general framework before I go in and I talk about some of the nitty-gritty? Talk some about those pieces of code we've been putting into the model. Any questions about where Java fits into AnyLogic? No? For the most part, you're insulated from it, but you do have to insert those snippets, and we're going to focus on those. Questions? No? Okay. So let's go dive into those snippets.